So in this video, we're going to be working with compound interest, right? It says a common application of exponential growth is compound interest. Compound interest is this interest paid on both the initial investment, called the principal, and on previous earned interest. So the formula is going to be very similar to the formula we used on the last video, but in this case, there's a couple of things that's going to change. So I got P, that is the principal, times 1 plus R over IN times N times T, 2N times T, right? Where A is the total balance, P is the principal or the initial amount, R is the rate, again in decimal, N is the number of times compounded in a year, right? How many times it compounded in a year, and T is the time. So Dave invests 300 in an account with a 5% interest rate, right? Let's start with identifying here my variables, and I want to write it like here in the middle because it's going to be the same for both. So I get a P equals 300, get the R equals 0.05. If he makes no other deposits or withdrawals, find the account balance after 15 years. So we know that T equals 15, right? It says that it's compounded semi-annually. So on this exercise right here, on this side of the exercise, so for this part, N is 2, right? Because it says semi-annually, so that means that it's going to be twice a year. So my formula is going to be A equals 300 times 1 plus 0.05 over 2 to 2 times 15. Okay, my recommendation here, whenever you can simplify something before putting it on your calculator, do so, right? Especially the exponent. So when you go to a calculator, you can write here instead of 2 times 15, you can write the 30 directly. So after finding this, we should have that is equals to 629 with 27 cents. Let's see the next one. So on this one, N is going to be 12 because it's monthly, right? So on this case, again, A, the principal and everything is the same, 300 times 1 plus 0.05 over 12, 12 times 15, right? So again, going to our calculator, this is 634.11 cents. Number 2, it says if 2,500 is deposited into a saving account, earning 8% annual interest, so the R is 0.08. How much will be in the account at the end of 25 years if the interest comes with the following frequency? So we know that T is 25, right? So quarterly, so that means that this is N is 4, right? So that means that we have A equals to 2,500 times 1 plus 0.08 over 4 times 4 times 25. So after going to our calculator, this should give you 18,111 with 62 cents. Letter B here, N equals 365 because it's daily, so that means that A equals 35 times 1 plus 0.08 over 4 over 365, sorry, times 365 times 25. So A equals to 68 with 58 cents. It says, when Amelia turned 6, her grandfathers opened a college saving account for her with an initial deposit of 500. So we know that P equals 500. The account earns 3.2% interest compound bi-monthly. So that means that it's twice a month. Bi-monthly, so that means that it's twice a month. So we know that R equals 0.032 bi-monthly means that N is going to be 24 because it's going to be twice a month, so 2 times 12. Okay? If our grandparents make no other deposit or withdrawals, how much money will be in the account when Amelia can access it at age 18? So we know that T is going to be 12, right? Because it's 18 minus 6. 18 minus 6. So A equals to P times 1 plus 0.032 over 24 to 24 times 12. Right? So that means that she's going to have 733 with 88 cents. Okay, so number 4 is telling you that it's semi-annually, so that means that n equals 2, right? When we plug all the information, we have the principal is 750, my rate is 0.004, n is going to be 2, right? We said it, and then t is 10, right? When we plug in that information, we have 780 with 58, right? But it's asking you right here, how much interest would she have earned, right? So that means that I gotta subtract the initial term, the principal, so 750 minus 780.58, it's gonna give you 30.58 in interest. Number 5, my principal is gonna be 1,000. R is going to be 0.02375, so I'm going to add 2 plus 3 over 8, and then move my decimal. N is 4 because it's quarterly. Then T is 2025 minus 1990, so it's 35 years. So at the end, you should have $2,290 with 55 cents. In some cases, interest is compounded continuously, meaning that the account is constantly earning interest. The formula to the right can be used to find the balance of the account. In this case, so A equals to principal, E times RT, right? Suppose you have 800 invested in account at 6% interest compound continuously. So here, continuously, that means that P equals 800. R equals 0.06, T equals 20, right? So I'm gonna go A equals to 800, E to 0.06 times 20. So A equals to 2,600, $56 with 9 cents. So number 7, I got that P equals 1200, R is 0.125, and T equals 5, right? It's continuously, so we're using this formula. So you should have at the end $2,241 with 90 cents. Lesson number 8 says Carla is investing 1,500 in a new 30-year retirement account. Determine which of the interest rate and compound periods shown to the left will be her best investment option. It says option A, 5.5 annual interest compounded monthly, right? So let's go option A. Option A, let's find out how much will she earn. So because it's compounded monthly, we're using the first formula. So that means let's start by identifying everything else here. So I get that P equals 1,500. I get that T equals 30. Right? So on option A, I got that R equals 0.055 and N equals 12. So A equals to 1,500 times 1 plus 0.055 over 12 times 12 times 2, 12 times 30. So in this case, A equals $7,181 with 8 cents. Let's check what happened when it's compound annually at 2.7. So we know that option B, we know that R is going to be 0.027. We know that N, in this case, there's no N because it's compound monthly. So P equals to 1,500 E times 30 times 0.027, right? So when we go to our calculator, this is 371.86, and clearly it's better for her option A because it's giving more money. And that's it for this lesson. May the force be with you.